Hello everyone, I'm Carlton McFadden, Vice President of Markforged Additive at Phillips Corporation Commercial Division.
And I'm Ron Tayebi, Customer Success Manager at Markforged.
I want to welcome you and thank you for joining us for Phillips Corporation FX20 launch webinar. At Phillips Corporation, we are on a mission. We've been here for 60 years, and we have been very excited to be the top supplier in the world of manufacturing technology. And then we decided that Markforged was the right partner to bring additive manufacturing to our customer base. And I have been very blessed to work with Markforged for many years. I started out with this company when they only had desktop printers. And so then in 2017, they changed the game with the X7, the first industrial printer. So they went a little bit larger. Then in 2018 and 2019, they launched the Metal X, and then they changed the game on metal. And now they've changed the game once again with the FX20, that is a production printer that has opened up new materials, bigger pieces, and that is where we're going with this technology. And so Ron, with that, could you tell me a little bit about the features of the FX20?
Absolutely. So the build volume of the FX20 is 525 millimeters in the X, by 400 in the Y, by 400 in the Z. So you actually can fit any one of our desktop printers in that build volume.
So that is huge. So let's talk about the speed comparison to the previous Markforged technology.
Well, if you take the fastest setting on our X7 industrial system, the FX20 is about 2.5 times faster than that.
That is a significant upgrade. Let's wrap it up and talk about hotter. So when you're going hotter, that actually enabled more materials to be opened up into the portfolio, including Ultem 9085 filament. Would you speak to the new capabilities and how that's working on the heat inside the chamber from the print head to the print bed?
Absolutely. So this is our first composite printer with a heated build plate and a heated build chamber. And the reason you need that is to print high temp thermoplastics like the Ultem 9085 filament, you need a heated chamber. Another feature with that is the print head. This is our first 3-nozzle print head. And the reason you need that is that the first nozzle prints your base material, either the Onyx FR, Onyx ESD, or the Ultem 9085 filament. The second nozzle prints the continuous fiber reinforcement, your carbon fiber, Kevlar, fiberglass, high strength, high temp fiberglass. And the third nozzle is support material for the Ultem 9085 filament.
And so let's dig into the last one, because you say this machine is smarter. So this was produced for the manufacturing floor. It's got an emergency stop, it has touch controls that are very easy to operate, but you also talked about smarter. So can you talk a little bit about the smarter technology that's in here and how it works with Eiger?
Absolutely. So this system is loaded up with sensors, okay? We often say our product is the part, not the printer, right? So every parameter of the part has been instrumented. So what that means is that we are constantly streaming data back, and that enables us to build a smarter product and a better product. And we often tell customers the worst day you're going to have this system is on day one. It's going to get better and better over time, which is not always the case with hardware.
Well, I can attest to that because we were very fortunate again to get one of the first FX20s in the world, and from the time we've pulled this out, we have been printing. And we have been printing a lot of parts, and it's been running non-stop. And so to get a look at some of the parts we've been printing, we're now going to turn it over to Kat Pomorski, who's a customer success engineer with Markforged, and Nate Bryan, an application engineer with Phillips Corporation.
Hey everyone, my name is Kat Pomorski, and I am a customer success engineer here at Markforged. Today I am in Phillips with Nate Bryan, and we're talking about the FX20. We have an amazing part, and Nate is going to walk us through how this part was created and why we created it.
Thanks, Kat. This is a large air duct component. It's printed out of Onyx, and it's got carbon fiber reinforcement around all of the bolt holes. We chose this design as a part to print on the FX20 to take advantage of the large build volume. It's 525 by 400 by 400 millimeters. The end result is a really good looking functional end use part, as you can see, with really nice surface finish. One of the problems that additive helps take and solve is supply chain issues. Instead of outsourcing end-use parts, our manufacturers are able to print their parts at the point of need, at faster turnaround times, and at a much lower cost.
Thank you so much for telling us about this giant part. It is incredibly cool. This part has continuous strands of carbon fiber in it, like Nate has mentioned, and we actually have a demo that Jesse Cranville, another application engineer with Phillips, will take you on that journey. So I'm gonna pass it over to Jesse to give you this Eiger demo on how to place that continuous carbon fiber into a part like this. Thanks, Jesse.
Thanks, Kat. Along with our devices and materials, we have our powerful Eiger software, and together they make what we like to call the digital forge that takes us from design to part quickly and easily. To access Eiger, we just open up eiger.io in a Chrome-based browser and import our part as an STL file. When I open the part, it takes me into our part view where I can configure the settings to print this. On the left-hand side, we can see our part details that will update when changes are made and saved. And on the right side, we have our part settings tab that will help us configure our parts to print. I'll start by just looking through and changing our base material. So our base material is onyx. Our reinforced material is going to be carbon fiber for this part. And I can also choose my printer type, which will be the FX20. For this part, we want to reinforce the inner bolt holes to distribute the compressive force that will be applied to the bolts. So I'll go into the internal view now to direct our carbon fiber reinforcement between the bottom or the floor layer and the top or roof layer of this part. Once the toolpaths and settings have updated for the internal view, we can see a transparent or X-ray view of our part. We can note that our part details are still reflected in the left-hand side of our screen that will still update as we make changes. And down here at the bottom, we can see that we have a bar here that represents the layers of our part. And by moving the mouse over, you can see the different toolpaths or features of this part as I move through them. If I click on this bar at any point, I can select a group of layers and make changes to where I want the reinforcement to be. So since we want to reinforce just the holes of this part, I'm just going to select the layers that represent this flange here. So I'll start at the very beginning. And I'll just highlight to the top of the flange. So now you can see down here by the bar here, we can see that we're editing 93 layers. And on the top right, you can see as well how many layers we're making adjustments to. So for this, I want to go ahead and enable fiber. And once I do, a couple options are going to pop up. For our fiber pattern type, we can choose to do the entire group of all of this to have reinforcement. I can also create a predefined amount of fiber layers. Here I can choose what type of fiber fill type we want. I can choose isotropic, which will do 2 rings around the perimeter, and it will fill the area of the layer with reinforcement in different patterns. With concentric, this will give me options to reinforce just the perimeter of the walls, the outer shell only, or the inner holes. For this part, we're going to want to do the inner holes. So I also don't want to reinforce this all 93 of these layers here. So what I'm going to do is change our fiber pattern type to stripes, and I just want to do 3. That should do the bottom layer, the top layer, and a layer in the middle. And we'll have 4 layers per stripe that are reinforced. So if I go ahead and create this group here, Eiger will reflect our changes in our model. And once Eiger is updated, we can see the changes have been made to our file. Currently, I'm still highlighted on the group here, but you can see represented in blue is our fiber type and where those patterns go in. And now all I have to do is, if I'm happy with my reinforcement type, I can save and hit print. Now let's go back to Carlton and Ron to talk about other applications.
Thank you for that insight. So now we're back. We're holding a couple of parts that were printed on the FX20. So as you can see, these are large parts. They'll do the job. And if you have applications in aerospace, automotive, oil and gas, if you have short-run manufacturing needs where you need strong end-use parts, this needs to be the first technology you look at. This is going to solve your problems. Ron, any other last thoughts?
Yeah, absolutely. These are, incredibly strong parts. It's a beautiful surface finish, and hopefully you can see that. 3D printing has been great for prototyping for a long time, but with the advent of these new materials, you can actually, as you can see, print these end-use parts. The continuous carbon fiber reinforcement enables you to replace aluminum. That's the most common thing we see for tooling, fixturing, jigs, is replacement of machined aluminum. And the other thing that gives you, as you know, there's a shortage of skilled labor out there as far as machinists are concerned. So these machines are lights out. They operate on their own and unattended.
So with that, we want to thank you for joining us for a first look at the FX20